Hello viewers, we have a question under applied mechanics and we have a cylinder of mass 2 megagram is rolled up an incline at 20 degrees at a steady speed of 6 km per hour. The coefficient of rolling resistance is 0.04 and so we are required to calculate the tractive effort and power required. And so let's take down our parameters. So we are given mass equal to 2 megagram, which is the same thing as saying 2 times 1000 kilogram. So mega is raised to power 6, kilo is raised to power 3. So if we have, this is 10 raised to power 3 and kilo is 10 raised to power 3. So 2 megagram is the same thing as 2 times 1000 kilogram. So that is it all. Let me further explain this. So 2 megagram is equal to 10 raised to power 6 gram. Okay, so but you can break this down into megagram. Megagram is 10 raised to power 6 grams, so you can break it down to 10 raised to power 3 kilogram. Of course, because kilo is again 10 raised to power 3. So when you have 10 raised to power 3 times 10 raised to power 3 to give you 10 raised to power 6. So 2 megagram is the same thing as 2 times 10 times 1000 kilograms. So we've gotten our mass. The mass is given, and we have that our speed v is 6 kilometer per hour, and so let's convert it to meter per second. So this will be the same thing as, this means 6 times, because of the kilo, so we are going to say 6 times 1000, and it is divided by hour, so it will be 6 to convert it to meter per second times 1000, because of the kilo here, divided by, to convert from second to hour is 3600. That's 60 times 60. So this will give us, if we punch a calculator, it will give us 1, okay, in meter per second. So this will give us 1.67 meter per second. Okay, if we do that conversion. So we've taken that, and we know that power is the question we are asked to find, and power is equal to PV. Let me say PTV, where PT here is the tractive effort and V is the speed. So since we know that power is tractive effort times the speed, so we have, since we've been given the speed already, so we have to find the tractive effort first. So once we find the tractive effort, we can now multiply it by the conversion we have in the speed, and that will give us our power. So we know that tractive effort, we denoted it using PT equal to FR plus W sine theta. But we know that this FR is a frictional force. FR equal to frictional force. And a frictional force is given by mu Rn, where mu equal to the coefficient of friction, or the coefficient, we call it coefficient of friction, or rolling resistance. It's the same thing. It's either you call it resistance is friction. Okay, so mu is coefficient of friction or resistance, while Rn equal to the normal reaction. But our normal reaction Rn is given by W cos theta. Reason being that normal reaction is acting in horizontal direction in this case. So we have W cos theta. And so if we bring the all of this into this equation 1, okay, let's call this equation 1 and call this equation 2. So if we bring the all of this interpretation into equation 1, we are going to have that attractive effort will be equal to, this Fr is mu Rn plus we have W sine theta. But we know that Rn is W cos theta. So we are going to have this attractive effort becomes mu Rn is W cos theta plus W sine theta. So we've been able to establish that, and we know that our mu is, from the question, is 0.04, and our theta angle is 20 degrees. So we are going to calculate our attractive effort now. So our mu is 0.04 times our W, the weight. Oh, we didn't take note of that. Of course, we know that weight is mass, as weight is mg, and we know our mass has been given to be 2 megagrams. So when we convert it to this, we are going to have 2 times 1000 kilogram times the g is acceleration due to gravity. So our weight there will be 2 times 1000 times 9.81. So the value of our weight is 19620. Of course, you know, weight in this sense will be measured in Newton. Okay, so we have our weight to be, weight here in this sense now will be 19620 times cos 20 plus the same weight here, 19620 times sine 20. So what is our cos 20? Cos 20 is 0.99, so we multiply it by 0.04 times this value, 19620, and that gave us 737.4. Okay, we can make it approximately 5 plus, so we also deal with this part. So our sine 20 is 0.34 times 19620. So that gave us 6710.4. And so when we add these two, so when we add these two, when we add this and this, it's going to give us that gives us 7447.9. Of course, since we are talking about effort, tractive effort, which is a force, the unit will be in Newton. Always remember to put the unit of whatever quantity you are calculating for. Is very important because it defines what you are doing. So we've been able to have the value of attractive effort, and so we can now calculate the power required. So power required, which is P, will be equal to PT times V. So attractive effort is 7447.9 times the velocity we calculated. This is the value of our velocity. We converted it from kilometer per hour to meter per second. And so it's 1.67. So 1.67. So we have 7447.9 times 1.67. So that gave us 12,437.9 power. So okay. So we have kilowatt. Okay. This is in watt. Or we can actually convert it to power in kilowatt by dividing by 1000. So this one will give us 12.4 kilowatt. So viewers, this is how to go about solving this question. We have a question, and then we're asked to calculate the tractive effort and power required. And so for you to calculate your power required, you have to calculate the tractive effort first. And then when you are done calculating the tractive effort, you know that your power required is tractive effort multiplied by the speed. And so we've gotten, this is the first part of the solution. This is the first part of the solution. And hope you can see it clearly. This is the first part of the solution. And then there's the second part, the second and final part of the solution. So for you to have you have in watt, and then you can now divide by 1000 to convert the power to kilowatt. Thank you.